This was brought in from a client. It's a air cleaner blower motor control that's got a mind of its own, and he's already tried to fix it. This guy's actually a computer tech that worked on this, but he doesn't. He gets a bit nervous when it involves AC. But he's already looked at the board and figured it was beyond his ability, and he wants me to make this just a single speed. Basically runs as soon as it's plugged in, and when you unplug it, it shuts off, obviously. I was brought this fan. I guess it's part of an air filter, and it doesn't work. And it's got a logic board on it. The local computer repair guy brought me this, and wanted to know if I could do anything. He figures there's a problem with the logic board, and basically what he's asked is if I can make this thing work so that when it's plugged in, it spins. He doesn't care about the logic board. If I can make it work when it's plugged in and run as long as it's plugged in. And I'm sure I can, because it's just controlled by, you know, triacs basically. But I thought, you know what, maybe just maybe we can get this thing to work, because after all, this is just a switching power supply in here, and operating this. There's a little bit of logic on here, and they control these triacs to select the different speeds. It's got a multi-speed motor on here. Probably got 4 speeds to it. So I mean, to make it work, it'd just be a simple matter of bypassing one of the triacs, because this is an AC motor. It's an induction motor. It's a capacitor down here, so I mean, it's easy to make the motor run. That's the easy part. This is my power coming in. The motor is going to have a bunch of wires going to it, 5 wires to be exact. A common for the motor, and then the 4 different speeds. But let's just see what happens when I plug this in and see whether I can actually get this this power supply to fire up. Because if there's no power getting to this, it won't work. Now this has a switching power supply on it. It's got this will be the switching transistor down here in this IC, which looks like an IC, but it's actually just a MOSFET. We got lots of circuit glue in here. This is the secondary side over here. That'll be a capacitor. That's the rectifier. There's a regulator over here. What is this? Like about a 5-volt regulator. What does it say on here? Can you see the number? LM 70 something 70. What do we got here? It's 7805. So that's just a 5-volt regulator. So now we know it just needs 5 volts over to this other board. But let's plug it in and just see exactly what it's doing first of all. I'm plugging it into my isolated power supply, and oh, there's lights on here. This thing is spinning. Well, I don't know what its problem is, but this thing appears to be working. This fan is turning, and the lights are working on here, so I don't know what the heck this guy's complaint is. Turn it off. It's touch sensitive controls, and now it's not working. Let's check the voltage on this voltage regulator to see whether we've got 5 volts getting over to this other board. Because that did come on, that fan did spin. $8 there, 4.9, so it does have 5 volts. So the power supply is working. It might be something on this board as foobar. There, see, it just came back on and the fan is now spinning again. Now it's really spinning. This one's power. Now it's off. So how this operates when it's working is this is just providing a control voltage down to turn on these optocouplers. Right now you have 2.8 volts on the speed number 2, and if a high speed one here has got 0, and if I am able to get it to go to the high speed one, that will go up to 2 volts. Let's see, it's not controlling. But there we go. Now you see that's just went to 2.8 volts. So something like this, it's pretty simple to get this to run. All I need to do is use a pull-up resistor to pull up which one of these optocouplers I want to have on. But the fact that this thing is behaving like it is and sometimes working and sometimes not almost leads me to believe that it's maybe a bad connection on this control board. Because you look down here, all these control lines come back to this IC over here. This IC is controlled over from this one over here. I'm just going to take a look at the connections here. Maybe, just maybe, there is a fractured solder connection on this control board, and that's where the problem is. Because sometimes it works and sometimes it doesn't. And it appears that if I just move the board a little bit, it works. Which makes me think maybe there's a bad connection on one of these ICs down here. So I'm going to go over this and take a close look and see if I can spot anything. I mean, the guy that brought it to me, he does micro soldering. He does changes ICs and stuff on Mac computers, so he's got all the tools for that. But as he put it, he doesn't work on line operated devices. He's scared of higher voltages, so he didn't really do anything on here. But I'm going to take a close look at these chips and see whether I can spot any connection problems. Let's use a microscope and just take a look at some of these pins down here. See if any of these pins will move when I touch them and try to pry them. I mean, the solder doesn't look very good on some of these, does it? My dental pick seems to have a lot of debris on the end of it under magnification, doesn't it? But yeah, we'll just take a look at some of these pins here, see if any of these will move when I kind of poke at them. You know, it almost looks like there's something wet under there, doesn't it? Like, what the heck? Is that... I don't know if that's flux, or the other guy tried to resolder this or something, but, or did that get moisture in it? Moisture in there certainly would cause us some issues now, wouldn't it? I don't know whether that's flux. So say this was how it was brought to me. It was brought to me yesterday, just like this. But I mean, that looks not very, doesn't look very good, does it? I mean, it looks like I just don't know whether that's flux from a previous attempt or whether that's just some contamination on the board from something else. This other IC here looks like it's got the same crap on it, doesn't it? Down here. I don't know if that's flux or what it is, but it's a mess, that's for sure. Or if it's just liquid, if it got wet, like condensation, well, that certainly could cause all kinds of problems, like, you know, short-circuiting things. You see what I mean? Like this is looking to be this pin here. I mean, something shorting out could certainly cause the symptom that we've got with this doing I'm using the microscope screen so I can see what I'm doing, because this is pretty fine work in here, but it makes it a little easier to see what I'm doing when I've got the microscope screen here. I don't use this microscope that often. I think I only used it a couple times since I got it. But it's nice to have, for sure. The smell that's coming off of this chip as I solder it does not smell like any flux that I've ever smelled before. I wonder if this is water or something got in there. I did kind of a flush with isopropanol first, before getting into here with the iron, but it is certainly giving off a smell, which is not a normal smell that's associated with like flux, rosin flux, unless it's some other type of flux. It almost looks like it is a type of flux of some type, but anyway, we'll just tack this IC back down, and the other one. I just want to see if it does anything different when I power it up, before I get in there and hardwire it for just one speed, which is what I was requested to do, is to make it work with just one speed. Lights in a little better. So I've just resoldered this unit, and I'm going to see whether it does anything different than before. I have no idea what these keys do, so we'll just see if they do things. Now this has a sensor on it. I don't know what this sensor does. Whether this is a humidity sensor or what this sensor does, but there's a little sensor on here that does something. If I turn it off, I turn it on, and I don't know what this button does, but it does function. Power. So slow speed. That's a timer. Dimmer. Yeah, this logic board appeared to not be doing something. I don't know what this is a regulator, I believe, over here. Let's just see what that voltage is. This is now not responding, but it was before. I wonder if this regulator's got a problem. What's the voltage there? 4 volts. 0. 3.3. So that's a 3.3 volt regulator, that one. So what I did is I ended up resoldering these components down here, and now this thing appears to be working. Maybe a capacitor was leaking and I heated it up, but I think the problem this thing was having was key scan. This is what detects the key scan for different functions. I think it's working. Yeah, test this thing for a bit and see whether I got it, but yeah. Appears to be working. That part appears to be working, so I guess we'll just test this thing for a while and see whether it's going to work. So I left the unit running through the night, and the controls have locked up on it again. So there's obviously another failure somewhere on this board here. It could even be the chip itself. There's no service data or anything. The fellow that owns it just wanted me to set it to go at 1 speed when it was plugged in. So we're going to just put a pull-up resistor in here to make the fan run as soon as it's plugged in, and we'll leave it at that. So first thing I'll do is I'll just kill the power to this board that's not working anyway. The power pin is this one. I know that because I measured it before. Over here there was 5 volts, so these were the inputs. So this one's the power pin, so if I cut this one, it will just shut the power off to this and the fan will stop spinning. Now, see, I can do this hot because I'm only dealing with a few volts here, 5 volts to be exact. I can take a 2K resistor as a pull-up resistor, and basically we'll just solder that onto this wire. and then I can use this and just connect it to whichever one I want to set the speed. So we'll just tack down this resistor. Again, doing this all while it's running because we're only dealing with 5 volts here, so what could possibly go wrong, right? And I got a phone call. The reason I needed to disconnect power going into this board is because I don't need it trying to turn on the different outputs. We don't want to have both, or have more than one of the power leads, because these are the ones that are going to basically send the 120 volts through these triacs, which have 120 volts on them. That's why I'm touching them. Your common, you got your hot coming in, AC in, and your AC neutral. I get them reversed. Like AC neutral's on the black wire, AC line is on the white wire. Yeah, right. What's wrong with that picture? They use a capacitor dropper here, and then that powers up the chopper side of the AC side of the switching power supply to generate your about 9 volts here, regulated down to 5, regulated down over here down to 3.3. But again, something on this board is got a problem. So the guy that owns it just wanted me to set it for a single speed so that when he plugs it in, it will turn on. Now we got our power, and we got ground, and we got 4 speeds: low, 1, 2, 3, and 4. Low, medium, high, and turbo. And if I touch the wire accordingly, you'll see that the fan starts spinning for the slow speed. And if I move it over to the next one, it'll go to the next speed. There we go. If I move it over to the next one, it'll go to that's the fast speed, and that one there is high. So there's high, and then there's turbo. Now I could put a 4-way switch just to switch this resistor, this 2K resistor, which is just providing the bias to turn on these optocouplers, which then of course turns on. These are optical couplers, so they couple by turning on an LED inside the optocoupler, it closes the phototransistor on the other side, which applies the bias over to the triac that then turns the AC on for the motor. So I could put a switch. If I had a 4-position switch, I could put a switch on here to switch between 1, 2, 3, and 4. But I don't have a switch. But if I did, well, I could put a switch here for low and medium and high and turbo. Now, since he didn't say what speed he wanted it on, I'm going to put it on this one here, just because I think it's it's fast, but it's not noisy. This is just for an air filter, right? It's for an air purifier. So I think I'll put it onto that one. And again, if he wants different speeds, we can put a switch in here if that was what was wanted. So to do that, I'm just going to basically solder the wire to the bottom of the board here to the terminal that goes to the medium-high position, and we'll throw some heat shrink tubing around here as well, just so that it's not as exposed. So I'll just nip that back a bit, get some heat shrink tubing, throw that on, and make this a permanent single-speed fan blower. Remember, we're in the reverse now, so that's turbo, that's high, that's medium, that's low, and that one's ground. So we're going to take it to this one here. Let's get some solder on here. And then I can give him instructions when he picks it up, saying if you want to select a different speed, I can even label these for him so that he knows if he wants to change the speed. This is 1, 2, 3, 4, and that's an X and that's an X. Don't hook up anything to those. So those are the 3 speeds. So now as soon as I plug in the power, it will start spinning at speed number 3. It'll remain spinning until the power is unplugged, which is what I was asked to do. So, mission accomplished. It'd been nice if I could get that board working, but he already tried that. And obviously there's an intermittent fault with it, that it works for a while and then it stops. So it could be any number of things, but I've now done what I was requested to do, make it a single speed, always on air purifier fan. So thanks for watching. We'll catch you in the next one. Bye.